So in this video, we're going to solve this problem where we're asked to calculate the equilibrium constant of the following reaction at 298 Kelvin. And what we're given are delta G's of formation values for our reactants and products. So to start off, we might want to remind ourselves of the equation we're going to use. And what we're going to use is our delta G at standard conditions is equal to negative RT ln of K. And so the first thing we actually have to find is our delta G of reaction. So delta G of our reaction, and the way we're going to do this is just going to be the sum of all the products minus the sum of all the reactants of our delta G of formation values. And so that's going to be our delta G of reaction. It's going to be, we'll take our products first, which is NO2. So it's going to be, there's two of them because of the coefficient. So 2 times 51.3. And then we're going to subtract from that all of our reactants, 99.8. We can get our delta G of reaction. And so we can go ahead and plug that into our calculator. So we have parentheses 2 times 51.3, close parentheses, minus 99.8 equals 2.8. So we'll come back and put that in. And that's, now put our units back in, so 2.8 kilojoules per mole. Okay, now we can go ahead and use our delta G equation. One thing we have to watch out for are units. So R is in joules, our delta G is in kilojoules, so we have to convert one of them. And so I'm going to convert delta G right now into joules per mole, so that'd be 2,800 joules per mole. Now we can take our delta G equation, and I'm just going to rearrange it to put it in terms of K. And so we can say the natural log of K is equal to delta G naught over negative RT. And now we can start to plug in. So natural log of K is equal to 2,800 joules per mole divided by negative 8.314 joules per mole times Kelvin times our temperature, 298 Kelvin. We can get natural log of K is equal to. So we're going to plug this into our calculator now. And so let's go back to our calculator function. And let's see, clear out what we have. And so we again had to get 2,800 divided by parentheses negative 8.314 times 298, close parentheses, equals, and so we get negative 1.13 equals, negative 1.13. And now all we have to do is get rid of this natural log. And recall the way we're going to get rid of the natural log is with the e function. So if you have something where you want to solve for our natural log of x, if you take e to the natural log of x, that's just equal to x. So this e function raised to the natural log will get rid of your natural log function. And so what we're going to do is we can say k is going to be equal to e raised to the negative 1.13. So how do you do that on a calculator? Well, on my calculator, just to show you my screenshot, if you find usually your natural log key, so here's my natural log key, and then notice here the secondary function of natural log is e to the x, and that's usually true on most calculators. So if I hit second and then the e to the x, I can then input my exponent. So we'll see what that looks like. So we'll go to our calculator and hit the second, and then e to the x. We see now we are our e raised to the negative 1.13 equals, and so k now is equal to 0.323. So we can come back and plug it in and say k is equal to 0.323. 0.323. And there's our final answer. Thank you.